Today we're going to dive into a pretty mind-bending idea from an author named Asibia. The whole thing starts with a 19th century physics equation, but it ends with the suggestion that our reality isn't what it seems. Yeah, it's a wild one, connecting electromagnetism to consciousness. So let's get into it.
Right off the bat, the author hits us with this. You ever get that feeling, that little inkling that the world around you is, well, a little bit off? According to this idea, that's not just you being weird. That's your brain, your intuition, picking up on a glitch in the system, a bug in the 3D operating system we call reality.
And this whole journey, this whole deep dive into the source code of our universe, it all kicks off with a question that sounds almost childishly simple. Why do radio waves fly? I mean, really think about it. How does a signal get from a tower to your car with nothing in between? The search for that answer is what starts to unravel what the author calls the universe's biggest trick.
Okay, so our first stop. We're going looking for what Asibia calls a glitch in the matrix. We're hunting for that first thread we can pull, the first piece of evidence that suggests our reality might be something else. And you'll never guess where we find it.
Believe it or not, the first clue is hiding in plain sight. It's buried inside one of the most important equations in all of physics, Maxwell's wave equation. Now, Asibia argues this isn't just some boring formula in a textbook. No, it's the first breadcrumb that leads us down the rabbit hole, revealing a massive secret about how our universe is actually built.
So how in the world does an old equation spill such a huge secret? Well, the biggest clue isn't found by looking at stars or galaxies. Nope, it's found in the one place we thought was completely empty. This is where we uncover the secrets in the vacuum.
Okay, this is where it gets super weird. So Maxwell, the genius that he was, takes the laws of electricity and the laws of magnetism and weaves them together with math. But then, look at step 3, the magic trick. In the final equation that describes a light wave, the magnetic field, it just vanishes. Poof, it's gone. It's almost like magnetism was just a conceptual tool, a helper for our human brains, but not a fundamental piece of the wave itself. It's the first real hint that what we see isn't the whole picture.
And this leads to a huge, huge problem for physicists, a real head-scratcher. The equation works perfectly, but it says that the speed of light is determined by the properties of empty space. But wait a minute. If a vacuum is supposed to be totally empty, a complete nothingness, how can it have properties? That doesn't make any sense.
And this slide just nails the aha moment. The old idea of a perfect empty void? It's wrong. Our vacuum actually has built-in specs, like a computer. In physics, they're called permittivity and permeability. But forget the jargon. Asibia's point is that this is like discovering that empty space has a fixed amount of RAM and a set processor speed. And these specs create a universal speed limit, the speed of light. This is a massive clue that our universe isn't just a big empty box. It's acting like a computational medium.
So, if space isn't actually space, but some kind of cosmic computer with its own processing limits, what does that make everything we see and touch? Well, this leads to the most mind-bending part of the theory. This is where the author says, reality is a hologram. The core idea here, which is actually based on a real theory in physics called the holographic principle, is that our 3D world, everything you see, the feeling of depth, the distance between you and your screen, it's not the base reality. It's a projection, it's a rendering, like a ridiculously high-definition, fully immersive video game. So what is this holographic principle? It's a wild theory that says the entire blueprint for our three-dimensional universe, I'm talking all the information that makes up you, me, the Earth, the stars, all of it, is actually stored on a distant, flat, two-dimensional surface. We're not in the universe, we are living inside the hologram that's being projected from that surface. Okay, I know what you're thinking. How on earth could that work? Let's just take distance. Asibia explains that what our brain sees as distance is just our interpretation of how connected two bits of information are. So on that 2D source code surface, if two pieces of information are strongly connected, what physicists call quantum entangled, our brain renders them as being close by in our 3D world. If their connection is weak, we perceive them as being far away. Space isn't a real thing. It's a visual illusion that represents data relationships.
This, of course, leads to the next huge question. If our reality is just a projection, then what does that make us? What's our role in this whole cosmic show? That brings us right to section 4, your brain, the decoder.
We've always thought of the brain as this super advanced biological computer, right? It takes in data and crunches it and somehow creates consciousness.
But in this holographic model, the brain's main job isn't to compute, it's to decode. Think of it less like a CPU and more like a really sophisticated antenna. It's not creating the signal, it's tuning into the universal broadcast and rendering it into the 3D experience we call life.
But that raises the ultimate question, doesn't it? If we are all just decoders running around inside a giant hologram, then who or what is the one doing the actual observing? And here it is, the most profound part of this whole idea. According to ACIBIA, there is no separate observer. Our individual consciousness isn't made by our brains, it's channeled through them. Each one of us is like a unique camera angle, a personal viewpoint for the universe to experience and observe its own creation. So if we're all just different facets of one universal system, one single consciousness, do our individual actions even matter?
Oh, you better believe they do.
And that brings us to our final and maybe most important section. The universe never forgets.
See, there's this fundamental law in physics called the conservation of information. And it basically means that at the quantum level, nothing is ever really deleted. Every single thing that happens, every action, every thought, is permanently etched as information onto that 2D source code layer. The universe's hard drive has no delete key, ever.
ACIBIA brings up this ancient phrase for this concept, tenmoka kaikai. It translates to something like, heaven's net is vast and has wide meshes, but it lets nothing through. This isn't about religion or morality, it's a perfect metaphor for the physical network of quantum entanglement that connects everything. Every action is logged in this cosmic ledger, no exceptions.
So why do our actions seem to have consequences, what some people call karma? Well, ACIBIA explains it as simple physics. Think about it like this. An action, especially a harmful one, creates a distortion, like a bug or static in the information field. The universe's operating system then automatically tries to correct that bug to restore balance. And that corrective force, it naturally bounces back to where the distortion came from. It's not a punishment, it's just the system's self-correcting protocol. And this is the final, powerful takeaway for how we live our lives. If we are all just projections from one single, interconnected field of information, then the separation between you and me is just an illusion created by the 3D rendering. From the universe's point of view, harming another person isn't just a bad thing to do, it's literally impossible. You're just harming another part of yourself.
And so this is where it all leads. ACIBIA reframes our entire lives as an experiment taking place in the Earth lab. We are the observers. We are plugged directly into the source code. So the final provocative question for all of us is this. Now that you've had a peek behind the curtain, now that you've seen a little bit of the code, what kind of reality are you going to choose to render?